Welcome to the lecture 2 of subject digital circuits. So in lecture 1 we were dealing with binary decimal number system and binary number system, and we have performed the conversion from digital number system to binary number system. So coming into this lecture, in this lecture we will be dealing with the following things. First one, we will be dealing with decimal to binary conversion. In lecture 1 we have dealt with binary to decimal conversion, so we will start with decimal to binary conversion. Second one, we will deal with what is done by octal number system. Octal number system. Third part, what is done by hexadecimal number system. Decimal number system. Okay. Maybe we will be dealing with octal number system and its conversions to binary and decimal. And in hexadecimal also we will be dealing with its conversions to as well as hexadecimal. And in hexadecimal also we will deal with its conversions to binary, decimal and octal. Okay. Maybe we will be able to complete only up to second point in this lecture, and we will keep the third point to the next lecture. Okay. So coming into the first point of this lecture, that is decimal to binary conversion. Decimal to binary conversion. There are different methods to convert a given decimal into a binary number. The most common method which we are using is known as double method. Double method. Okay, so to convert decimal to binary, the most easiest method is double method. That is why we are proceeding with that. Okay, so we will start with an example. Okay, so coming to the first question, convert 52 to the base 10 to a binary number. Okay, that means already the base is 10, which means 52 base is 10. Therefore we can write 52 as a decimal number. 52 as a decimal number. Now, how to convert this 52 to a binary number? Okay, so I am going to explain about the double method here. Okay, so for binary number system, base is equal to 2. So divide the decimal number by 2 until you get 0 at last. Okay, so 52 I am dividing by 2. 52 by 2 is 26. And remainder is 0. Again divided by 2, 13. The remainder is 0. Again divided by 2. So you will get 6 into 2 as 12, and the remainder is 1. Divided by 2, you will get 3, and the remainder is 0. Again 3 divided by 2, answer is 1, and you will get it as remainder as 1. Again divided by 2, here you will get 0. And the remainder is 1. Okay. Now count from and write from bottom to top. That means 52 to the base 10. We can write it as 1 1 0 1 0 1 1 1 1 0 1 0 to the base 2. Okay. So you have to count. So you need to divide 52 until you get 0. and remainder. Okay, so that is an example of decimal to binary conversion using double method. Okay, I will show you another example also. Convert convert 105 to the base 10 or 105 to the base 10 to binary. So here we are having only integer part. So if we are having only integer part, you should divide by 2. So we can write as using double method. Using double method. Okay, 105. 105 divided by 2. It is 50, 51, 52. 52 into 2 is 104. Remainder is 1. Divided by 2. You will get what? 26. Remainder is 0. Again divided by 2. 13. Remainder is 0. Divided by 2. 6. Remainder is 1. Divided by 2. 3. And remainder is 0. Divided by 2. 1. Remainder is 1. Divided by 2. It is 0. And the remainder is 1. And then count from bottom to top. Therefore, we can write 105 to the base 10. We can write it as 1101 001 to the base 2. Okay. So I have shown two examples how to convert a given decimal number to a binary number. But now I have explained only about the integer part only. Now I will give another example, including the decimal parts also. So coming to the third question. Convert 163.875 to the base 10 to binary. Okay. So here it is divided into two parts. So 163 is the integer part and 0.875 is the decimal part. So first you take the integer part. And do with the double method. That is 163 divided by 2. 81 means 162. 81 remainder is 1. Divided by 2, you will get 40. Remainder is 1. Divided by 2 is 20. Remainder is 0. Divided by 2, 10. Remainder is 0. Divided by 2, 5. Remainder is 0. Again divided by 2, 2. Remainder is 1. Divided by 2, 1. Remainder is 0. Divided by 2, it is 0 and remainder is 1. Okay. So that is So that is the integer part. That means you can write 163 to the base 10. 163 to the base 10 we can write it as 101 000 11 to the base 2. Now I have converted the integer part. Now how to take into account the decimal part? I am going to take into account the decimal part or fractional part. So it is 0.875 into 2. 0.875 into 2. That is 10. Remainder 1. 72, 14 plus 1, 15. 1. 8 into 16 plus 1, 17, remainder 1. So it is 1 here. Again, next one is 0.750. 0.750 into 2. And write it. So you should write 2 into 0, 0, 5 into 2, 10, remainder 1, 7 into 14 plus 1, 15, remainder 1. So it is 1.5. Again, 0.500, 0.500 into 2. 0, 0, 5 into 2, 10, 1. Yeah, it is 2 into 0, yeah, it is, answer is 1. Okay. Again, 0.000 into 2. So you will get it as 0.000, etc. Okay. So now you should write, you should take the whole part of it, that is 1, 1, 1, and write in this order. Write in this order. That is, you can write it as 0.875 to the base 10. You can write it as 0.111 to the base 2. Because if you are proceeding further, the next digits will be 0. Therefore, we can write 163. Therefore, we can write 163.875 to the base 10. You can write it as 101.111 to the base 2. Okay. So that will be the final answer. Okay. So that is how you are converting a decimal number to a binary number. I will give you one more example. Convert 27.85 to the base 10 to binary. Okay. So here we are using only double method. First you take the integer part. That is 27 by 2. That is 13. Remainder is 1. Divided by 2, 6. Remainder is 1. Divided by 2, 3, 0. Divided by 2, 1, remainder is 1. Divided by 2, 0, remainder is 1. Therefore, 27 to the base 10. We can write it as, you write from bottom to top. This 1, 1, 0, 1, 1 to the base 2. Now, coming into 0.85 part. So, 0.85 into 2. It will be 5 into 2, 10, 1, 8 into 2, 16, 16 plus 1, 17, 1. So here it will be 1.70. You take 0.70. 0.70 into 2. What is it? It will be 1.40. Then you take 0.40. 0.40 into 2. What is it? This is 0.80. Then we take 0.80. 0.80 into 2. What is it? It is 1.60. Then we take 1.60. 0.60. So it is 0.60 into 2. Answer is 1.20. Then we take 0.20. 0.20 into 2. What is it? 0.20 into 2 is 0.40. Okay. So you can stop at any bit because here it will continue. Therefore, we can write 27.85 to the base 10 is equal to 11011 point. We should write in this order, right? Right here and here. And it does 0.1101 1101 10. And if you need to add furthermore decimal points, you can have 0.40 into 2. That is 0.80. That means again you will get 0. So you can have 0 to the base 2. Okay. So that is how you are converting a decimal number to a binary number. Okay. So with that I am ending with the first topic of this lecture, that is decimal to binary conversion. Now next one is octal number system. Next one is octal number system. Okay. Listen by octal number system. Octal number system. Okay. Octal number system means the number of symbols. The number of symbols used is 8. That is radix or base equal to 8. Okay. That means they are using symbols or digits. So the digits which is used in decimal number system, in octal number system, digits in octal number systems is given by some R. We are having system R 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So these are the elements in a these are the elements or digits in an octal number system. There is already 8 elements. There is already 8 elements or 8 digits. Now here the base of the number system is 8. Now if you need to convert this octal number system into a decimal number system, so I will give an example of octal to decimal conversion. Okay. Say octal means I am having I am writing as on minus 1, on minus 2, etc. O0 point, O minus 1, O minus 2, etc. O minus k. Here O stands for the octal digit. So we can write it as to convert to decimal, we can write it as on into 10 into 8 raised to n plus on minus 1 into 8 raised to n minus 1 plus etc. plus O0 into 8 raised to 0 plus O minus 1 into 8 raised to minus 1 plus O minus 2 into 8 raised to minus 2 plus etc. plus O minus k into 8 raised to minus k. Okay. So this is how we are converting octal number system into a decimal number system. Okay. Now here what is an octal number system? Here you can write 8 is equal to 2 raised to 3. So what is the importance of this 3? That I will explain it. That means 2 raised to 3 means it is consisting only of 3 bits. If you are considering a binary number system, you can write with the help of 3 bits. Okay. So that the application of these 3 bits that I will explain while we are converting it into a binary number system. Okay. Now let me explain the octal counting. Octal number system counting. So I will deal with the decimal and octal only right now. I will write up to 25. Decimal, octal. Again we have decimal and octal. I will write decimal up to 25. So I am having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Okay. Here 0, 0, you can add the 0, 1, 2, 3, 4, 5, 6, 7. Okay. After 7, you should start with the next bit. So after 7, you can add the 1, 0. Okay. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Okay, so now you have reached 7. So again you have to restart from 0. That means 7 becomes 0, add 1. So 2, 0, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. Okay, now you have reached 7. Same 8, 7, so it is 3, 0. So 3, 0, 3, 1. Again, if I am doing it further, decimal, octal, 25, 26, 27, 28, 29, 30, 31, 32. So you will get a 3, 1. This is 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7. So you have reached 7. Change it to 0, it is 4, 0. Okay. So this is how octal counting is done. Okay. So I think you have got the counting of octal number system. Okay. So regarding octal number system, and now we have explained about what is meant by octal number system, how many digits or what is the radix of the octal number system. Then here we are having 8. Radix 8. So you are having numbers from 0, 1, 2, 3, 4, 5, 6, and or digits of 0, 1, 2, 3, 4, 5, 6, and 7. We are having 8 digits, and I have given a formula to convert octal to decimal. Here 8 is the base. Okay, and n stands for the position. Okay, position in the integer part, and k stands for position in integer part, and k stands for position in fractional part. In fractional part. Okay. So now I will explain about octal to. But now I will explain about octal to decimal conversion. Okay, and octal to binary conversion I will take through an example. Okay, so first I will explain about octal to an example of octal to decimal conversion. I will take an example here. Octal to decimal conversion. So the first question is convert 4057 point 067 the base 8 to decimal. Okay, so how to convert this octal number system to a decimal number system. Okay, so you can write like this: 4057.067. First you assign the positions. So this is 0, 1, 2, 3, minus 1, minus 2, minus 3. This I can write it as, if you are converting it into decimal part, the decimal part I can write it as 4 into 8 cube plus 0 into 8 square plus 5 into 8 power 1 plus 7 into 8 power 0 plus 0 into 8 power minus 1 plus 6 into 8 power minus 2 plus 7 into 8 power minus 3. Okay, this we can write it as 4 into 8 power 3 is, you can write it as 2048 plus 0 plus 8 into 5 is 40 plus 8 power 0 is 1 into 7 is 7 plus 8 power minus 1. Okay, you can write it as plus 8 power minus 1 is, 1 second, let me take the calculator here. Yeah, 0 into 8 power minus 1 is 0 plus 6 into 8 power minus 2, that is 6 by 64, that is 0.9375 plus that is 7, that is 0.01367 So if you are adding it, you will get it as 2048 plus 0 plus 40 plus 7 plus 0.09375 plus 0.013671. That comes into 2095.1. That does 2095.107421 to the base 10. So this is an example of how you are converting an octal number to a decimal number. One more example. That's fine. So here multiply the numbers with respect to the positions and the base. So here the base of the number is 8. So you need to multiply by the position powers of the base. Another example, convert. Second question is convert 25.71 to the base 8 to decimal number system. Okay. So you write 25.7571, give the positions. This is 0, 1. This is minus 1, minus 2. Therefore, we can write it as 2 into 8 power 1 plus 5 into 8 power 0 in decimal format plus 7 into 8 power minus 1 plus 1 into 8 power minus 2. So that is equal to 16 plus 8 power 0 is 1 into 5 plus 7 by 8 plus 1 by 64. So the answer comes into 16 plus 5 plus 7 by 8 plus 1 by 64. The answer comes into 21.890625 to the base 10. So the decimal equivalent of 25, that is, we can write it as 25.71 to the base 8. That means the decimal equivalent of the octal number 25.71 is given by 21.890625. So hope you have understood the octal to decimal conversion. Okay. Now here we need to discuss about one more conversion. That is decimal to octal to binary conversion. I have already mentioned about octal to decimal. Now we need to deal with octal to binary conversion. Right? Yeah. Octal to binary conversion. Octal to binary conversion. So this is an easy method to convert octal to binary conversion. So I have a question here. Convert 367.52 to the base 8 to binary. Okay. See, basically octal number system. Octal means the base is 8. Base is equal to 8. So 8 we can write it as 2 power 3. So here you should write each number or each digit as 3-bit binary. Okay. That means if I am writing 367.52, okay, I can write 7 as 111, 6 as 110 in binary, 3 as 011 in binary. That is in 3 bits. 5 I can write it as 101. 2 I can write it as 010. Therefore we can write 367.52 to the base 8 is 0 1 1 1 0 111. This is the decimal point. 101 010 to the binary. Okay. Means we are taking 3-bit by 3-bit. Okay. So this is an example of octal to binary conversion. One more example. Convert 27.86 to the base 8. So no, there's no 8 is there. So 8 is not permitted. So we can have 46 to the base 8 to binary. Okay. This 27.46. 7 in 3-bit binary is 111. Here we are having 010. 4 is 100, right? Yeah. 6 is 110. Okay. Therefore we can write 27.46 to the base 10. No, sorry, to the base 8. You can write it as 01011.100 to the base 2. Okay. This is how we are converting an octal number system to a binary number system. Okay. So we have dealt with octal to binary. Now coming into binary to octal conversion. Next one is binary to octal conversion. Okay. Let's start with an example. Question number 1. Convert 110.101.010 to the base 2 to binary. Sorry, to octal. Sorry, not to binary, to octal. This is a binary number system. So you have to convert to octal. To convert to an octal number system. Okay. So in octal number system, you know that the base is equal to 8. So 8 is equal to 2 raised to 3. So you need to group 3 bits. So you need to group 3 bits. Okay. So write it as 110.101.101.010. Okay. So first you need to have 3 bits combination. So this is 3-bit, this is 3-bit, 3-bit, 3-bit. If 3-bit is not available in the left side, you add 0. That is all. Okay. So what is 110? 110 is 6. 101 is 5. Point. What is 101 is 5. 010. 010 is 2. Okay. Therefore, we can write 110.101.10110 to the base 2 is equal to 65.52 to the base 8. Another example I will show you, binary to octal conversion. More example. Second example in binary to octal conversion. Convert 1011.101 to the base 2 to octal. Okay. So what is basically octal? Octal is of radix 3. So radix 8. So that is equal to 2 raised to 3. So you need to group 3 bit by 3 bit. So you have 1011.101. So here 3 bits is there. Here 3 bit, but if there is no 3 bit, you add extra bits. Okay. So what is 0011? 011 is 3. Point. What is 101? That is 5. So the answer is 13.5 to the base 8. Okay. So 001, the decimal equivalent is 1. 001, the corresponding number is 3. And 101, it is 5. So it is 13.5 to the base 8. Therefore, we can write it as 1011.101 to the base 2 is 13.5 to the base 8. Okay. So hope you have understood binary to octal conversion. Okay. So we have started the lecture with an introduction lecture with the decimal to binary conversion, octal number system. In octal number system, we have dealt with this part. Now we will go to part 3. Part 3 will deal in the next lecture. Okay. In octal number system, we have done conversion to binary, binary to octal, octal to decimal, then hexadecimal conversion. Now the remaining one is hexadecimal. Okay. Now that hexadecimal part we will deal in the next lecture. Okay. So with that, I am ending with the lecture on this one, binary to decimal, decimal to binary, and octal conversions. So in the next lecture, we will be dealing with hexadecimal number systems and its conversions. Thank you, and hoping you to have a good association in the next lecture also. Thank you.